Good morning, good afternoon. Hello, ladies and gentlemen. Very nice that you're all here in the call. This year the world changed significantly and also our mode of work. Because of COVID-19, virtual meetings have been an essential part of our work since March 20, and we all became user experts with these well-usable software tools we have. Nevertheless, I would like to mention an important rule for this meeting. Please mute your micro during the presentations. Therefore, thanks in advance. My name is Bernd Feierabend, and I'm responsible for Bosch Engineering and Production Services, an international engineering service provider for planning, implementing, and optimizing production systems and manufacturing facilities. With our holistic approach, lean, safe, and green, as well as our Bosch automation and digitization know-how, we are able to offer an end-to-end solution, which means we're offering services from the product idea to the production for our customers. Thereby, we're creating highly efficient and lean value streams. This is the touch point today. We want to share our thoughts and also our ideas about the production in the near future, especially in high-cost regions. We structured our talk in 3 parts. First, I would like to give an insight about our holistic engineering and execution approach. Secondly, Sarah Scholz will present her planning approach for a waste-free production through lean management. And last but not least, Amin Badawi is sharing his expertise and experience in digital engineering. At the end of each presentation, we have a particular planned time slot for questions and answers. But before we start with this, a few words about us, Bosch Engineering and Production Services. Let me start with our history. We have more than 60 years consulting and execution experience in around about 1,000 projects to build up international production networks for high volume and also small scale manufacturing. Out of it, we gained our basic know-how to support you, our customers, all around the world with smart concepts and smart solutions. We are able to provide support in China, India, North America, Mexico, and the US, and also in Europe, mainly in Germany. So we can operate our business worldwide in 7 countries with 10 offices and roughly 240 project managers and process experts. Our performance portfolio ranges from strategy development and technology management through the product development process. We support also from production planning to the procurement of machinery and right up to the startup support for production facilities. The planning tasks can be done digital-wise, like real-time simulation of material flow and also manufacturing processes. Next, I want to combine our portfolio with the holistic approach, lean, safe, and green, to achieve production excellence. When I'm talking about production, I'm always meaning the full spectrum, from inbound to outbound. With our overall approach, lean, safe, and green, we are thinking that we can fulfill all necessary requirements for best-in-class production best. Lean in our understanding is the main pillar to be able to produce something in an appropriate way. We see lean as the basic for all production, but we need also a best fit in automation and digitalization of production to be competitive in quality, cost, and delivery. In our model, SAFE contains safety and security for humans, facilities, know-how, and data. Here we are able to create boundary conditions in a production plant to protect all sensitive areas against abuse. The pillar green is the field where we work on energy efficiency to reduce carbon oxide. From my perspective, this will become a very important task for the future. I recognized that the industry is striving to create emission-free supply chains for their products. Beyond that, in addition to the financial rating, in the nearer future, the rating agencies will rate the production industry also in CO2 emission. Therefore, we need, on the one hand, clearly optimized supply chains, and on the other, efficient production sites. Furthermore, for international production, our approach supports the compliance of regional legal requirements. In our eyes, very significant due to the globalization in production. Here you can see an overview about our service portfolio in the area of lean. We are working here in the themes lean production, lean management, automation and digitalization, coming from the product side up to the production. But now to the really important part of this meeting, the presentations from Sarah and Armin. The next 40 minutes, for sure, will certainly be exciting and interesting for us. Hello, Sarah. Now the stage is yours.
Thanks, Bernd. Hello, everybody. Also from my side, I'm happy to be here today and to get the possibility to hold a keynote speech about the topic lean management within the production planning process. In the lecture, I will introduce you to our modular planning approach, which enables us to develop right from the start waste-free value streams, as well as to perform the entire production planning process efficiently. First of all, I would like to give you some information about myself, just that you know who you're dealing with. My name is Sarah Scholz. I'm an industrial engineer, and currently I'm working as a project manager at Bosch Engineering and Production Services. After my graduation from university, I started as a junior consultant at Bosch's Industry 4.0 unit, so-called Bosch Connected Industry. Afterwards, I worked as a production planner within the manufacturing sector of sensor elements at the Bosch plant in Eisenach. After the time as a production planner, I moved back to Stuttgart and started as a project manager at Bosch Engineering and Production Services. In my current role, I'm working on different projects within the field of production optimization and manufacturing planning. I guess most of you know the topic of lean manufacturing. Nevertheless, I will begin my lecture with a short introduction to the topic. Afterwards, I will give you an overview about our holistic modular planning approach, as well as give you more information about the individual planning elements. At the end, I will close my speech with a short overview about the fundamental success factors. If you ask someone, what does lean management actually mean? Most people would say lean management was developed as a part of the Toyota production system in Japan, and it's a method that aims to avoid waste in your processes and to increase your added value. The basis of this statement isn't wrong, but we see that companies who are successfully applying lean management differ from other companies by seeing it more as a kind of a management philosophy to build up a self-learning organization that has on one side, of course, the lean and efficient processes, but on the other side also employees who are able to drive continuous improvement. Since lean management was derived from the production system, at the beginning, most companies applied it only to their direct corporate areas. After a while, the companies found out that they also have improvement potentials in their indirect areas. Therefore, they started also implementing it to their indirect areas like the product development or sales. Always with the same goal to increase the value add, avoid waste, and to implement the culture that drive for continuous improvement. At Bosch, we actually took the same way. We implemented in 2002 the Bosch production system, which was based off the lean management thinking. And about 10 years later, we started implementing lean management also in indirect areas. To close the definition part, The only difference between lean management and lean manufacturing is that the content of lean manufacturing only relates to the production areas, where lean management can be used throughout the whole company. Most manufacturing companies have their own production system, which consists of the goals, principles, and methods that they use. For example, you could have a production system that aims to have lean and connected value streams. What we saw in the past was that most production systems use lean principles and methods in the brown field. This means they use them to optimize their existing value streams, but they forget to use these elements at the beginning in the green field. This means at the part where you are designing new value streams. Therefore, at Bosch, we developed our so-called modular planning approach. It is a systematic approach for planning new waste-free value streams, and it's based on a workshop concept. The application of the different workshop elements supports you to systematically consider all fundamental things that are relevant for planning a new or redesigning an existing value stream, to ensure that you have no waste in the new value stream right from the start, and it supports you to execute the entire production planning process efficiently. Because the workshop sequence already starts in an early stage of the product lifecycle, and that the participants of the workshops are not only employees from product development and production departments, but also from logistic, quality management, purchase or sales, the approach also increased the teamwork within the simultaneous engineering process. Okay, so let's have a look on our modular planning approach. First of all, please don't feel overwhelmed by this slide. I will guide you through it step by step. And one more hint, I have prepared one-pager for all workshop elements. In order not to stay on this slide for the next 12 minutes, I will show this one-pager while I'm presenting. Due to the limited time, I will keep this brief and I'm not going into detail on the one-pager. However, we will send you the presentation after the event so that you have the possibility to get more information about the workshop content. In the bottom line, you can see the different phases of product and process development, starting with the innovation process until the SOP and series production. As I already mentioned, the approach we are looking right now relates to the development of new value streams. Therefore, everything that follows SOP means the optimization of an existing value stream by lean principles and methods is not part of this keynote. The phase of the product engineering process before the start of development offers the best possibility to influence the product design, the manufacturing processes, and the value stream design in order to avoid any waste in the future value stream. For this reason, we recommend to apply some single workshop elements on a higher concept level within this phase. An optimal outcome would be that the rough concept of the possible design variants are compared and initially checked for manufacturability. At this stage, an important point is also the decision which added value we want to create ourselves and which is to be bought in. Therefore, an initial definition of make and or buy is made in the phase before start of development. Now we are moving to the phase after SOD, where the main workshops will be performed. Premises, targets, and risks. In this workshop, we will clarify and collect all the given targets and premises for the upcoming production planning project. An example for a target could be the OE rate that the production line has to achieve after SOP. With premises, we mean the internal and external framework conditions. For example, the estimated sales volume for the next years. In addition, at this stage, we determine the project risks and the REEF measures to reduce them as far as possible. Last but not least, in this step, we also define the degree of automation for the first investment stage. Value stream design. The value stream design workshop is used to describe the target state of the planned production. On the one hand, for the situation at the start of production, and on the other hand, for the steady state. This is carried out into two steps. In the overall value stream, we harmonize the material and information flow from the supplier to the customer over all value stream sections. In the value stream design on the production process level, we describe the production internal processes. Scaling. As we all know, a stepwise investment strategy reduces significantly the investment risk. Scaling focuses the planning on natural cycle times and leads to low waste manufacturing concepts with adjusted automation, high availability and flexibility, and low demand of investment. For the planning of assembly and production system, the determination of the best possible steps of investments is an essential task. For this task, we use the scaling workshop. Within the scaling workshop, alternative production and assembly concepts are developed and evaluated. First, we define a basic concept for all production steps. This also consists of the estimation and collection of the individual times for the different production or process steps. These times can be calculated with MTM standards or any other time measurement method. In the following, the systematic improvement of the respective bottleneck station results in a further production or assembly concept with a higher capacity. For example, your first calculated cycle time was 90 seconds, and by optimizing your bottleneck station, you are able to reduce the overall cycle time to 80 seconds, which is then your further production concept or scenario. Dfma, Design for Manufacture and Assembly. In addition, we have a Dfma Workshop element. As the name suggests, this section aims to consider issues of the technical manufacturing and product design in an early stage of the product engineering phase. The result of the Dfma Workshop is a list of measures for optimizing the product design with the aim to allow a simple, secure, and cost-efficient production. If there are some Bosch colleagues attending our event right now, they might be thinking, why does the Dfma Workshop start after the scaling workshop? In our company, the order is often the other way around, because at Bosch, the Dfma Workshop is usually the first point where the production department gets deeper informed about an upcoming new product or a new product generation. However, the companies that Bosch Engineering and Production Services support are more often medium-sized companies. And we have gained the experience that in these companies, the employees of the production departments are already involved in the product engineering process in an earlier stage, also without a separate Dfma workshop. Nevertheless, sometimes it happens that when we define the different production steps within the scaling workshop, that they are popping up some topics that influence the product design. For example, during the definition of the production step in which the new product is placed in a workpiece carrier, the question arises where to grab the product in order to place it in a workpiece carrier. If this scenario wasn't considered before, this upcoming question could lead to an adjustment in the product design so that the product can be transferred without any damages. In cases like this, our scaling moderator will do an exemplary deep dive into the Dfma approach. With this, we want to enable the employees of our customer to do the Dfma clarification for further upcoming topics by themselves. However, if the customer still wants to do a separate Dfma workshop, we are happy to offer a further workshop moderation. Now we are coming to our line design element. With the previous planning steps, value stream design, scaling, and Dfma, the production concept has been defined. Now we begin with the design of the work system within our line design workshop. Depending on the automation level, we either do a lean line design or an automated line design workshop. If we plan manual and semi-automated work systems, we use the lean line design workshop, which aims the design of flexible work systems. These systems can be adjusted to a changing customer tag through the adaptation of the number of employees working in the line without productivity loss. And if we plan a production line that is predominantly automated, then we use the automated line design workshop. Here, the focus point is the best possible line balancing of the individual production stations. Flow-oriented layout. With the workshop element flow-oriented layout, we arrange the systems and devices that were designed in the framework of the line design in a process-oriented manner. The goal is to minimize transport and handling complexity. Apart from the systems and devices, we take all necessary adjacent areas, storage areas, and buffer areas, as well as the traffic routes into consideration. Okay, so let's come back to the overview chart. The flow-oriented layout workshop finalizes the conceptual planning. Following this, the detailed planning of the systems, processes, and work standards take place. Since the content of the detailed planning is quite a lot, this information will be shown in the next production talk in the middle of March. Before I move to the next slide, just one more important hint. It is not always necessary to do all of the shown workshop elements. The variation of the needed workshop elements depends on the individual conditions of your production planning project. If you need to develop a production or assembly line for a completely new product, then we would recommend you to carry out all of the workshops. But if you want to do a relocation of a production line and you plan to take over all the processes without any product design changes, then you could skip the DFMA and scaling workshop. The main benefit of applying our modular planning approach is that at the end you will receive a flexible manufacturing system that is scalable to the always changing market requirements. In addition, you identify the project risks and needed product design adjustments during an early stage of the planning process. And you ensure a high maturity level of lean manufacturing for your future production system. To achieve the named benefits, make sure that you select the right workshop elements needed for your individual production planning project. Ensure the active participation of all relevant key functions. This means 100% attendance and focus during the workshops. In order to run them efficiently, further ensure that you prepare all needed input data. Finally, the completion of the open tasks, which will be collected during the workshops, is our last hint for a successful application of our modular planning approach.
What I want to show you today is my experience and motivation for digital engineering, an overview over the products of digital planning, and then I will show you some examples with simulation models of a material flow simulation and also in an AGV simulation. At the end, I will make a summary and give a conclusion to it. So, what are our experience and our motivations? We have gained our experience with digital tools through numerous projects in recent years. With over 18 projects in 2019-2020 alone, which we are carried out with about 1,800 consultant days, we were able to achieve a lot with our 6 simulation experts. One of the main success factors is the faster ramp-up of production. By applying material flow simulations already during the planning phase, many errors can be eliminated. That would delay a ramp-up during commissioning. Especially the material flow simulation has convinced us. This can also be seen in a number of projects we have carried out here. Digital twins and process simulations are 2 topics that are not yet widely used, but they will become more and more important in the next few years. Some of the main causes of waste in the indirect area are data inconsistency, inefficient change management, limited planning data reuse, no agility for increasing planning dynamic and complexity, and challenge of increasing number of planning constraints. One measure for this is the provision of a platform that can be seen as a single point of truth. Such platform is called MPP, for example, the Manufacturing Process Planner. With this application, development and production documents can be managed and linked with each other. Thus, a synchronization in case of modification between bill of material, bill of production, bill of equipment is given at any time. Also, the revision of planning stages can also be carried out with this application. The application line designer is a CAD program for the development and creation of detailed layouts of your buildings and manufacturing areas. Beside of the execution of the first collision checks, bill of equipment and bill of production can be synchronized to MPP very easily. The process simulator is a powerful application to simulate process flows very accurately. Especially robot gripping movements and human-machine interaction can be done and optimized in advance. Collisions, programming and control logics, and economic issues can be checked and optimized early in the planning phase with the help of Process Simulator. The real advantage lies in the virtual commissioning of the process sequences. Currently, the effort of such simulation is still quite high, but already today more and more machine manufacturers are mapping their products using a digital twin. Thus, in the future, the effort to perform a process simulation will be significantly reduced. As I mentioned at the beginning, material flow simulation is currently the most used application from the digital toolbox, since the cost-benefit factor is currently the greatest. While the other applications usually have to be started very early in the planning phase to make the benefits worthwhile, this application is worthwhile at any time in the project. It is not only suitable for planning new plants, but also for optimizing existing plants in terms of material flow, output performance, bottleneck analysis, resource planning, and above all, inventory management. With a manageable effort, entire production hall can be mapped and simulated in terms of material movement, supplies and staging. The use of transport vehicles, the number of employees required and their movements can be also checked and simulated for different scenarios. On my next slide I will show two projects where we used this application. The product cost management application is useful to keep the product and project cost always up to date, especially if you want to compare different scenarios or concepts with the economic view. There will be a higher comparability. It is much more efficient to prepare quotation once you set up your complete production and product structure in a digital twin. The last application is mandatory to hold everything together. The data backbone is the interface to all applications. Data are pushed bidirectional via Teamcenter. But only MPP, the manufacturing process planner, can manipulate data stored in the backbone. Even though the advantages of these applications are very obvious at the first sight, we also need to talk about the current difficulties. In some places, the bidirectional data exchange does not work yet. There are still some activities going on to improve the data communication. Special for process simulation, manufacturing process planner and the cost manager, you're beginning from scratch to create a digital twin first. The effort is still very high for it. This will also take some time until the benefit will be greater than the effort. The first practical example, which was carried out last year, is a simulation of the complete logistic for a new production building which extends over 2 floors. The main task of this simulation were visualization of the material flow of the not existing production line, implementation of all logistic processes and their interactions, and the continuous monitoring and optimization and support for the current planning. The simulation itself has the opinion to calculate the number of empty containers, forklift drivers, trucks and employees for the repacking and packaging area, the number of AGVs which are needed, the AGV trips per hour, and the utilization of the conveyor system. Also, the simulation and utilization of the point of use provider are one of the main tasks of the simulation. For this, we calculated 60 consultant days, which means that one simulation expert support the team over 3 months. At the end, we got the result that we have the validation of the delivery cycle and logistic control, a mathematically supported supermarket design, and a high increasing of the transparency in the process chain. In the next video, I show you some insights of this simulation. This is an official building which is being converted for a new function. On the ground floor, you can see the complete goods incoming process, the warehouse and the commissioning area. The simulation has, for example, determined the necessary parking spaces you can see here, the numbers of employees and the number of necessary vehicles you need for this distribution process. The sum of the necessary cleanroom activities, the duration of the transfer of the goods to the goods carrier, and the number of the goods carrier and the length of the conveyor system, what you can see here in the next step, was an essential output from the simulation. With the shuttle cam, you can see how the products move now from the ground floor to the first floor. Beside the transport of the goods to the first floor, the complete supermarket, the cyclic material supply of the production, as well as the collection of the finished parts could precisely simulate with plant simulation. Here you can see a section of the production facility. Finally, of course, the complete delivery process must not be missed. Here, too, the finished parts were transported via goods carrier to the ground floor again, where they were commissioned by the employees and handed over to the shipment department. The second practical example includes a simulation of automated guided vehicles that are to replace a manual material supply. The task were to create a simulation model based on the current planning status and layout, and also to integrate the real AGV data from the supplier and the station data. The simulation has to calculate the required AGVs depending on the loading and unloading times and waiting times. Also the number of stations needed to reach the OE target. The routes and the controls of the AGVs was also part of the simulation. The result of the simulation was that we had at the end the ideal number of AGVs to achieve the OE target, the presentation of the wholly fleet management and the manufacturing execution system, and also we had at the end the transparency for future planning activities. Finally, I would like to summarize the topic of digital planning tools and point out the advantages that result from them. With digital planning in a virtual environment, I gain planning security above all. Particularly with complex tasks, I can detect and correct many planning errors at an early stage. As a result, I'm significantly fasting during commissioning and series ramp-up. Indirect activities, especially in change management, can also be reduced through the use of data management tools. Also, the presentation of results in a virtual environment creates efficient reporting within the company and the project. There is certainly still potential to improve the interfaces between the applications. At one point or another, a solution often still needs to be developed. In addition, digital tools cannot be used by everyone from one day to the next day. It requires high expertise, not only in production planning, but also as well in the ability to develop methods with programming language to make the simulation executable. Thank you. Thank you for your attention. I hope I was able to give you a good picture of the digital tools we rely on. Thank you.